So many thanks to all. Welcome to this meeting from Commodore User Europe, December meeting 2024. And I'm quite happy to say that because it's actually now the 4 years that we started. So in March, or when we start 2025, it will be actually the fifth year of Commodore User Europe. So at the beginning, it was more or less like just trying to copy a little bit what was happening with the Toronto pet user group. You know, I participated once or twice there, and I thought it was really nice. But on the other hand, we wanted to put some structure as well with an agenda and stuff like that. So I think so far it went not too bad. We have about 2,000 people following the page on Facebook, more or less the same on YouTube. In total, 100,000 views in total if you combine YouTube and Facebook. So I think that's quite nice. 71 videos so far on the YouTube channel. So if you don't know what to do during the Christmas holidays, if you have too many days and you are in need for some tech entertainment, then you know where to find interesting things to look at. And of course, I say it every time, but I think without you, the speakers who are presenting something today, of course, there is no event. So many thanks once again to all of you. Like every time, so we are now streaming live on the Facebook page. It seems to work. In addition to this Zoom call, with Zoom, I will start for each of the speakers. Every time you start with a talk, I will start also a recording by Zoom, and so that's actually the video that will be posted later on YouTube, and also the MP4 file will be made available for you. So if you have your own channel, you can also post it there or on your website or whatever. Yeah, so that's the way it will work. And of course, we are then recording and live on Facebook. So we are in Europe. There is this RGPD regulation. So if you don't consent to being recorded, then you should leave at least the Zoom call. That's the way to go. So I will maybe just go to the next page if I can with this. Yes, so that's the agenda for today. There will be a little change then after Maciej and the disk drive simulator for C16, 116 and +4. Then instead of Marco, we will switch to Micah because he has to leave he's a bit sharp with the timing. So then we will continue with Marc and Dendo with the assembler in BASIC, and then we will switch to Marco. So we'll have Marc, then Marco, UG or Micro G BASIC, and to end the session with another Maciej with Tony and the adventure game there. So first Maciej, I would say I will stop now sharing my screen. You can, I guess you can start sharing yours. And just give me 1 second. I will start the recording. Okay, so the floor is yours, Maciej. Thank you.
Okay, thank you for having me this evening. I'm going to present you very shortly, very briefly, my project TCBM2SD. Maybe it's not the easiest name to say, but I'm not good at naming things. And what is it? It's a cartridge for C16, 116, and +4. It's also a 1551 pedal replacement and a 1551 disk drive simulator. And what are those things should be more clear at the end of this talk. But first, maybe a little about me. I have been involved with Commodore since 1992, but only Commodore 64 and 128. My main focus was on GEOS and things that were specific to Commodore 128, some hardware expansions. I had memory expansion in my Commodore. and some little hardware projects. I paused my Commodore activity in 2001, but I came back in 2021 with a Bitcoin miner for Commodore 64, and there's my scene handle, YTM or Yataman of Elysium. In the following year, Krzysztof Dąbrowski, Brush of Elysium, has ported this game, Amaurot, from Atari to C64, and I continue his work, and I ported this to Commodore 128, and using some tricks specific to Commodore 128, I made it faster, and also it works in both 40 and 80 columns. And there was also this. Back in 1999, I have disassembled GEOS, and then I wanted to check something on Atari, 8-bit Atari, and it ended up with me porting GEOS to small Atari. But it's not today's topic, because the topic today is that in June, I became a +4 owner for the very first time. And that was a problem because I was a newbie. So how do I do anything with this computer? I got so much used to Action Replay and the servant on Commodore 128 that it was just not convenient for me to use, load and run commands. I had connected this to 1541 disk drive, but it was slow. I didn't have GFIDOS at that time. With SD2 IEC, it was faster, but still slow. Ultimate 2+ works with that, but it's not convenient to control when you don't have this integrated native menu. You have to do it over the Ethernet with Telnet. There is tape card that was almost what I needed, but it doesn't support disk images. So I wanted something that had speed, that was convenient, and what could be my options? First, I wanted to check out the native solutions. For those of you who don't know this range of computers, this is a 1551 drive that was designed specifically for these computers, 16, 116, and +4. It has this nice graphite finish to match. It has almost the same DOS as 1541, but it's 4 times faster than 1541. And this is because it uses parallel data transfer, and this kind of connection is named TCBM for reasons lost to time. And you can see on this photo that it's connected to a cartridge. And I thought maybe I can have one of those, but it would be faster, but still it wouldn't be convenient because it runs on floppies, and I wanted to have something with a USB or SD card. But let's take a closer look at the paddle. That's the cartridge. It's called a paddle. It may be confusing, but yeah, it's a cartridge. On the back, it has a pass-through port for another cartridge or another paddle if you want to have two 1551 disk drives. I couldn't find the photo, but I think that 2 of them connected back to back to +4 would look just funny. There is a cable connector for this parallel cable. So this is something like a burst or parallel connection from 1541 to user port on a Commodore 64. The difference is that user port in Commodore 64 is handled by the I/O chip that is inside the computer, but this one is handled by a 3-port interface, a chip that is on the cartridge itself. It has 3 ports, but 2 of them are just 2 bits wide. Another example of a cost cutting from Commodore. And the last element on this cartridge is a PLA, which decodes address and CPU bus. So this is all explained very nice and very extensively in Michael Steele's article at that page. I highly recommend it. So I did a internet research, and it turns out that there is nothing like a hardware 1551 emulator, something that would resemble Pi 1541 or U2+. There is no SDIAC that would use this kind of parallel connection. In fact, I couldn't even find attempts or talk about it. There is no other device that would understand this protocol, but PLA has been replicated, and a bigger brother of this 3-port chip, the one that has 3 8-bit ports, has been replicated as well. So I had an idea that maybe I try to do something like that. So I wanted to start with something simple and replicate just the paddle part, this cartridge. And then I would want to connect it to something that would talk with this TCBM protocol. And this something would simulate, not emulate, because it's difficult, but simulation is easy. The 1551 or TCBM device, it would just respond in a way that the 1551 would do. And maybe at some time in the future, that could be integrated with SD2 IEC. And after a month or so, I had this. This is the first revision of the cartridge. And it has it's based on modules, because I wanted to make it easy to solder, to build by yourself. It has Arduino Mini Pro. This microcontroller has 2K of RAM and 28K of flash. There is a complex programmable logic device in here. That's the only part that is difficult to solder. It handles the port emulation and the PLA decoding. And there is a power module, because we need to go to the 3.3 volt world. And there is the SD card socket also as a module. And there is a place for edge expansion edge connector. But at that time, I had no idea that these are impossible to buy and impossible to find. It seems the only source is to harvest it from a main board of a C16, but I just don't have heart to do it. And this is how it looks like in a cartridge shell. So it looks stylish, although should be graphite. I started to use it daily, so I knew that it was convenient and fast. At that point, I knew that I don't want to port it back to SD2 IEC anymore, that it's just fine as it is. It has some firmware problems. It didn't work with CPU replacement parts that some of these computers have, like original CPU was broken and it was replaced by a 6502 or 6510. And it also had issues with GFIDOS. And I recognized that there were missing features. So that's the next revision. And the missing feature were the 2 buttons to switch to the next and previous disk image. The connector for the cable is also available here. So a real 5051 drive can be connected to that. And in fact, 2 weeks ago, I got a confirmation from someone that indeed it works with a real 1551 drive, because I don't own one. And there is another part that I missed, and that is a socket for a ROM chip. There are some components under this footprint, and I realized that maybe I don't need those components because I have a programmable logic chip next to it. So after a small patch, this is where we are today. That's the 3rd revision that supports directory deload dsave commands from kernel without any special software. It just uses the protocol that the +4 expects. It supports a subset of these commands like scratch, rename, change directory, make directory. It supports disk images, the big 3 ones, 64, 71, 81, but also lesser known 82 and D80. They are quite similar to the 81, but bigger. It can work as a device 8 or 9, changed programmatically or via jumpers. It's fast, in fact, twice as fast than 1551 using kernel routines, or 6 times as fast as 5051 using fast loader. In fact, that is like 23 times the speed of 1541, so comparable to Dolphin DOS or Speed DOS that also use parallel cable. And it also works as a cartridge, so it has 1 or 2 30K banks. And let's try to do a little demo right now. I need to switch my capture device. Oh, there we have it. So that's the startup screen of the +4. And you can already see that we have two cartridges, 1 and 2, that occupy the function keys. One of them is BASIC 7.0, which implements some commands from the BASIC 7.0 of Commodore 128. And the other one is Calc Plus, just a spreadsheet from Commodore. I put it here because I had no better idea how to use it. Yeah, let's switch focus to the disk drive. This +4 is not connected to anything. It only has this cartridge. And we can check the disk status. After a reset, it reports like this with a firmware version 0002, the two numbers at the end. Standard directory listing works. We have some directories here and also this boot file. This boot file will be loaded whenever one tries to load the star file, and it will work from as long as you are not inside the disk image. So in this case, it can be any file. It can be like a startup file for a game that would be distributed on an SD card. But here it's just a directory browser. This is directory browser version 1.2, and it has been patched to use the fast loader features from TCBM to SD. And if I go into a folder that has lots of files, then you can see that it loads quite fast, and we can start one of those. Now it's loading, and now we have it, and it started up. And yeah, right now I'm in this games B folder, but if I deload star file, and in fact there is a shortcut for this on a +4, shift and run stop, then I have a browser again, and I can go up, and I can show you how the disk images work. Here are games that I have patched to use the fast loader or just loader from TCBM to SD. There is a Pets Rescue, Turbo Outrun, Prince of Persia, Alpha Ray, Lemmings, Bard's Tale, which is a multi-disc game, and Lycia. As you can see, these are D81, D64 disk images, and they just appear as directories. So I can start up Lemmings. Now it's loading, and after a few seconds of decompressing, we will have the game. The game starts, loads the level, and yeah, there it is, Lemmings on a +4. So right now I'm in the disk image. I can go up by just issuing a command, and I am back on the level of FAT file system. So if I go up, and here I can show you there is a GEOS that I have patched to use the special loader for TCBM. I said that this save doesn't work on the disk images. It works only when you are saving to the FAT file system. But GEOS has this loader, and I put the feature into the firmware so that single disk blocks can be saved within a disk image. And this was enough to make GEOS support. So I can start GEOS. Now it has loaded. Now it's loading desktop. And here we are. I don't have a joystick or mouse connected here. I will be using keyboard shortcuts. Now I'm reaching to the buttons on the cartridge, and I will switch the disk image, and I will open the disk. And yeah, now we are in a completely different place. Let's try to open one of those documents. Now GeoWrite is loading. And there is GeoWrite. Now it's loading the document and the font. And yeah, there it is. So I will switch back to the presentation. So what comes next? I'm quite happy with this hardware and the firmware already. I will continue software patching because it's highly rewarding and fun when you figure out something. Maybe Pi 1551 would be possible. It would be based on Pi 1541 because those drives are so similar. It would be a cycle exact emulator that would be capable of running the drive code. So that would be full 100% compatibility. The hardware would be much simpler than Pi 1541 because this is already working on the 3.3 volt logic. So all you need is just to have some wires connected to Raspberry Pi GPIO, but it doesn't work as a Linux application. It works as an ARM program. So any help with the ARM bare metal programming would be needed. Where to get it? Everything is open source. You can find all the firmware, software, hardware designs, patched games, and the source code for patches as well on the project's GitHub page. I'm going to publish this also on the PCBWay, so anyone can order this as a manufactured device. But I have some of this with me, so if you want to purchase that, you can contact me, and I might have one at that point. I wanted to say at the end that this wouldn't be possible, certainly not within this time span between June and October, without all the people who made a choice and made an effort, because I know it is an effort, to open source the hardware and software projects, to document them and publish. And there are benefits to that because there is already a project that is based on my work already, and that's fake 6523 that replicates this small 28-pin port chip inside the paddle. So now anyone who has a broken paddle can find a replacement port chip to that. So yeah, that's what I wanted to show you today. So thank you for your time and attention.
Well, many thanks to you, Maciej. I guess it's time to open for questions. We have quite a few people in the attendance room. Maybe while people are still thinking about the question, I'm checking on Facebook if there are any questions posted there. I don't see any, but I had one. I see. So on the first of all, so you're using this Arduino, the small Arduino there. Did you change anything between the 1.1 and the 1.3 version, or is it exactly the same part that you're using there?
It's using the same firmware, and 1.1 and 1.2 are almost identical. They differ only in the fact that there is a slot, a socket for ROM, and those two buttons. But
Okay.
yeah, rest of the design is pretty much the same.
Okay.
And yeah, Arduino is the limiting factor here. I took something that I knew. I needed something that works on the 3.3 volt logic, but it's a limiting factor because it has not enough RAM to do anything else except this basic compatibility layer.
Yeah. So there as well on the memory management. So you mentioned so the RAM, the 2K RAM, 28K flash, but then you have also this. You have the SD card reader that could be used as a kind of swap space for memory. Is this something that you intended to use, or that you could use for some?
No. SD card is only for the storage for Commodore.
Mhm. Okay. Any question from the attendees? And I still have one. I think the community of C++, Commodore Plus 4 users is quite, it exists of course, but it's much less, or it's big, it's smaller than the Commodore 64 or 128 community. Do you have many users providing feedback? How?
Yes, I announced this on the Plus 4 World forum, and it seems that every Plus 4 owner is there. And I wanted to say hi to you guys because it's a very nice community, very welcoming.
Yeah, actually, it's true that the Plus 4 community, it's indeed smaller, but on the other hand, you have probably more technical guys than on C64 128. You have a lot of people who are just, let's say, collectors and gamers. Of course, we have also a lot of technical guys, but I think nowadays the people who are using the C4, they are much more tech oriented, or let's say only more than if you look proportionally maybe then.
And perhaps mostly in Hungary, as far as I remember, it was quite popular in Hungary.
Okay,
I think.
I didn't know. Okay.
Yeah, that was exactly the same situation as with the small Atari that was popular in Poland. So Plus 4 was popular in Hungary. I'm quite amazed with the amount of games that has been ported to that machine. I wasn't actually aware of that.
I am amazed that they were ported without using sprites.
Yeah.
That's
what I know. This I know because about the game that I will be talking. I know there was also port for Atari. The guy who did it was there was no sprites in use, and it was like a hard challenge.
Okay, I don't want to diss Atari right now, but after porting Geos, I knew that sprites on Atari are a bit useless. So
yeah, sort of. Yeah, you have a faster CPU, so you can really try to attempt to do some software sprites in a bitmap mode, but nonetheless, all the charm of the faster CPU is gone then. Yeah.
Mm-hmm.
I don't see any more questions here, but if you have any questions, just maybe type them into the chat box. I will. So thank you again, Maciej. I will stop the recording.
Thank you.
And then we can call the next. So for people who join in when it was already started, we have a little change in the agenda because Micah has has a short or sharp agenda today. So we will continue with Micah, and then Marco will take the slot of sorry, Marco, yes, will take the slot of Micah later on. So Micah, if you are ready, you can unmute yourself and just wait a second. I will start again. No, sorry, so just stop a second. I need, you can record in the cloud or record on the computer. There it is. Floor is yours, Micah. Thank you.
All right, awesome. Thank you. And thank you, Marco, for agreeing to switch. I'm in the US, so still middle of our day, and my daughter's got a football match here in a little bit. I want to get to that. So yeah, my name is Micah Bly. I like to work on software. I'm not a hardware guy, so that last project looked amazing. But I'm here to talk about software and about one of my favorite computers of all time, which is a Commodore 700, which we will take a look at. Okay, so just, regular background. I started out on the US version of the ZX81. It was my brother's, then he got a 64, then I got a 128 at one point. I used that for years. Eventually went to Amiga 500, and then to the most beautiful computer in my mind, the 3000. These days, I tend to spend my time on a couple different sets of computers and 6502 computers. So this CVM2 or the Commodore 700, we'll talk about that today. I still have my 128. And then I've been getting into these new retro computers. The one I ended up on rather randomly is by Phoenix. So this is a person in Canada. She makes them. And I've got a 6502 one. This also comes in a 6809. If anyone's a 6809 programmer, I'm not, but I'm excited to learn about that. There's people who've ported OS 9 to it. And then I like 68K Motorola's too. So, you know, I love Amiga DOS 1.3 and 3 and 3.2 and all that stuff. And I love the old Toaster Macs. I don't love programming for them as much because they got all that stuff, memory manager stuff, which drives me crazy. But then just a few days ago, I got another Phoenix, which I ordered like 3 years ago, but since Steph makes them by hand, you know, sometimes it takes a while. This is kind of like the ugly stepchild of the family. Only a few of us like it, but I love it. It's going to be bare metal for me, so I'm going to write OS from scratch. That's got a 6840 in it. I'm excited about that. But today we're here to talk about this guy. So I don't know if everyone even knows what the Commodore 700 is. Sometimes it's called the CBM2, or you'll see B128, B256, BX128, well, not BX128, BX256. A lot of names for this thing. Mr. Shatner there is going to sell it to us. So this strategy of this was designed to come out in 1982, timed to be with the 64 launch. You know, kind of in North America, they were going to pitch the 64 as your home computer, your family computer, whatever. Kind of secondarily, maybe you could use this for business. In Europe and in Canada, but mostly in Europe, the CBM 700 was meant to be the replacement for the PET in the small, maybe the medium-sized business. PET had a lot of market share even in 1982 because the PC hadn't come out, it was a year late coming to Europe. And the Commodore folks there were just like dying to have something to replace the PET because it had gotten old. So Commodore came up with this guy. And what is it? Okay, first of all, it's really fast. It's twice as fast as anything else that's a 6502. I'm not sure how fast an Apple III was. Possibly it was 2 megahertz, but since no one bought one, it doesn't matter. It had out of the factory either 128K or 256K, and it could go all the way up to 890, basically a megabyte of memory in 1982. This is a crazy number. You know, I think an Apple II then was probably shipping with like 16K or something. It had 80 columns, so it's got the same lack of graphic capabilities as any PET, you know, 80 column PET. So green screen, 80 columns, text only, PETSCI. It has a SID chip though. So again, they haven't launched the 64 yet. The 64 is going to get the SID chip. They have the SID chip. They're going to put it in everything they have. They don't even know how they're going to use this in a business machine. And because it's running at 2 megahertz, you can't like read anything out of it, but it still makes sound. It does not have the horrible slow IEC, you know, thing that, you know, really kind of crippled the 1541s. It has the nice PET IEEE 488 port, so you get all your PET peripherals work and they're super fast. There's a version of this that came with 2 built-in disk drives. It's like a megabyte of storage with 2 disks. It's amazing. It has BASIC 4 plus, so 4 is the final PET BASIC. 4 plus is like that, but even better, and it's got some of the stuff you'd get on a Commodore 128 with BASIC 7. Doesn't have the music stuff, and it doesn't have, of course, the graphics commands. But other than that, it's really cool. So it's got this is actually my favorite Commodore BASIC ever. And it has a built-in RS-232 because they know people are going to want to communicate. You're not going to need to have a UART on a chip like you might want for a 64 if you want to do faster comms. But most amazingly, it's going to have all this expansion. So it's got coprocessor slots, it's got a big expansion bus, and Commodore is pitching, we're going to sell you an MS-DOS with an 8088 on it. We're going to sell you CPM86, again, 8088, and we're going to sell you a Z80 CPM board. You can have, in fact, there's a whole brand of these which is going to come with those out of the factory. That's their strategy for this. Unfortunately, the reality is there's no MMU. So they are trying to make this 6502, which can only address 64K of memory, work for this 896, and they can't quite get it right. And they go through revision after revision of the kernel, and there's timing problems, and it's flaky. It takes them an extra year. So the 64 has been out there selling. It's probably, I don't know, sold 500,000 units or something already by the time this is ready. So it gets ready, and Commodore basically just throws up their hands and surrenders, and they never really launch it. So I'm pretty sure that all the ones in the UK were trashed, like literally trashed. That's what the users group at the time was saying, but I don't know if that's true. I have no idea what happened to the ones that were for Germany. There's a reasonable amount of these floating around Europe, so I don't think they were trashed, but I don't know what happened to them. In the US, they were all sold off to a third party called Protecto, which was what we call like the liquidation service. So they just resold things really cheap. So you could, for years, 83, 84, 85, you could see advertisements like this in black and white in the back of computer magazines, get a 128K Commodore system for, less. There was even a while where they were selling them at the same time the real C128 had come out, and obviously a lot cheaper, right? Protecto was based in Chicago. And so there was a user group that started up around there called the Chicago B Users Group, CBUG, and it had one of these, had a guy who led it, started it, was kind of crazy, very motivated, wouldn't take no for an answer. He browbeat Commodore into giving him the kernel code and releasing it for these machines. He flew over to Europe and he browbeat the Commodore guy there to let him take out the prototype DOS boards and CPM boards, and he brought those home. He also browbeat a couple of companies into finishing software that they had started for the B machines, but had given up when Commodore dumped it. Fairly amazing story, kept the thing going for like years, like literally 3 or 4 years. So there's actually an interesting little community of people who are like these orphaned Commodore users. Well, what's going on with it today? So there's a lot of stuff going on, and most of it is in this, that I'm aware of anyway, is in this Facebook group, Commodore CBM2. So if you're not in there and you're interested, join. Be great to have some more folks. So Steve Gray is a longtime CBM2 guy. He's been dinking around with just cutting some traces and doing some little basic electronics work on the, and seeing if I can get TTL output out. He's been dinking with colors. Vossi is another longtime CBM2 god. I'm not sure if he's created this from scratch or he's recreated one. I know there was a couple high-res boards, one in Canada, one in Germany, I think. He seems to have made one. So it's black and white, but you get, I don't know what this is. This is probably 720 by 350 or something, because this is the high-res text behind it. Pretty amazing. Michał Pliben is in Switzerland, I think. He's got several products here. You can buy these when he's got them in stock. So this one is MS-DOS running on your Commodore, better than the Commodore one. I don't think he recreated the Commodore one exactly. I think he created his own version of it. Seems to be stable. I'm dying to get one if he ever cranks some more out. I don't know if you can see in the back, but kind of in the back, vertically standing up in here, you can see his VGA card. Just a great way to get VGA output. Again, he's using one of the different expansion buses. He also has a CPM card apparently. So a lot of really great stuff going on. Steve Gray with another cartridge for doing a kind of 4-in-1 on the system bank. And Vossi, because if the other graphics card wasn't amazing enough, check that out. That's full color, amazing stuff. Go watch his video. It is incredible stuff. It's such a great time to be alive to see this stuff. People doing all these cool electronic projects with, machines that they're stretching, right? There's also new software. So Space Chase, that came out a few years ago, but that really inspired me to get in, get doing stuff. You can also, there's Lair of the Lich King. That's my game. It's a roguelike. Some people here have done it. You can get that. And I also make some utility software. This is a 2-pane kind of like Midnight Commander file utility and browser or text viewer and stuff like that, because that's useful to me. So it'd be great to have other people writing code for it. What do you need to write code for any new computer that you don't know? Well, you need reference material. So let's see what we got. Commodore when the VIC-20 came out, didn't have anything, and then they had a good user guide. But then after a year or so, they got the reference guide that was 300 pages. Then with the 64, 486 pages, even more, like all this great technical information, everything you need to know. 128 came out, 750 pages. Amazing. Like, just like everything you need to know. And look, it lies flat and you can just work heavily at it. So surely we've got something as good for the B machines. No, we don't. So you could get this little manual that came with it, shipped with a little manual. It's about 100 pages. There's a couple variants of it, but they're about the same. Really very, not much information there. You could get what Protecto called the B128 Programmer's Reference Guide, which was typewritten, like on a typewriter. It's pretty unpleasant to work with. And apparently was written by one of the guys at Commodore UK who was just dying to sell this machine to his customers, and and had been preparing this by himself because Commodore wouldn't write one. He wrote it himself in his spare time, and Protecto and ended up using it. But it's a little quirky because he wasn't a tech writer, and he didn't have access to the engineers. And then the last thing is maybe the Seabug Escape. So this is the newsletter once or twice a year from that users group in Chicago. There's actually a fair amount of technical information in here supplied by some users. And some of these, Elizabeth Deal, you'll see her writing articles for compute for years before and after this. So some really good amount of technical stuff. Very, 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 very quirky. Mix of levels because these are users writing stuff in. And that's about it. So I was like, well, I'm writing code for this. I want to have something that I can use. What can I do? Can we not have something better? And I thought, well, maybe I'll just reformat this Protecto reference guide so that it's in a nice font and I can read it. And I can like do searches. But I started doing it, and then I started finding things that bugged me and didn't make sense. And I, sometimes the sample code didn't work and I didn't get it. And I just started then I just got crazy and I said, well, screw it. I'm just going to write a new one. So what I wanted is something that I could have bought in 1982, would have looked like something the Commodore made, would have been as complete as the C128 reference manual, would have been styled similarly. The fun thing I wanted to do with this is to write it as if it was still 1982. So it's got snooty comments about Apples and stuff and Ataris probably, hopefully. If not, I'll add some Atari stuff into it to insult them. It should teach you how to use the computer as if you're a new computer, because a lot of things back then, people did not actually, know how to use the computer. This was often their first computer. It should teach you how to program BASIC because that's what things did back then. But it should also have everything you need as an experienced programmer. So, memory map, kernel breakdown, basic breakdown of every basic function and a statement, screen codes, ASCII codes, all that stuff, everything you need. Try to pull that all together in one place, and it should lay flat so it doesn't close on you when you're trying to type something. So this is what I came up with. This is the first version. It's not quite done yet. I've got some work to do, and this is a few of the pages. But it's got a nice shiny cover and back cover. It's going to be bound. I think in the end, it's going to end up being a spiral bound. I tried to do this disc binding, and I was printing this on an A3. So, one page on each, 2 pages per A3, and then you slice it down the middle. But it turns out it's really hard to actually slice something in exactly the same page width every time. And so the edges of it are kind of uneven. And also the disc binding, I'll show you a picture of that. It's great, except for that if your paper isn't thick enough, they tend to want to come out, and you don't want to lose pages of your thing. So I'm gonna switch to. I talked to the Mega 65 guys on how they did theirs, and they did on-demand printing, and it looks great. I got to play with one. I would have preferred to have something that was like either the comb binding of the like the 128 manual, but I think that you can't get that anymore, and the wire binding is pretty good. So this is one of my earlier versions of it. I'm happy. I think it's going to look great when it's printed. I don't think it's going to cost much more because it turns out it costs a ton of money just to buy. If you're just a person buying all this paper, it's fairly expensive just for the paper. So, next steps for me, I've got a little bit more to I format it to do the on-demand printing. Graphic chapter is done. I got a little bit more work. I might add something about how to burn your own ROMs, because you could burn your own. You could tweak the current BASIC if you want to. I want to clean up the music chapter a little bit. I've got the basic start is done, but I need to write some machine language examples. I try to have machine and basic, assembly and basic examples where, for the advanced chapters, where it matters. Music, obviously, you want to know how to do that in assembly. I need to rework the RS-232 chapter. Anyway, some stuff there. But what would be great if there's anyone who's got one of these and is interested, I'd love to have some feedback and even bug testing if people run through it. It comes with a little disk of all the sample programs too, so you don't have to type anything in, although you're welcome to. So if anyone's interested, there's my contact information. Probably the best one is my channel on the Phoenix Discord. That just happens to be the one I'm on all the time. But also the Facebook CBM2 group is good. I have my own Cromware Discord server. That's mostly Lich King. But I do check it fairly reasonably. And then you can email me, but so much spam, I probably will miss it. That's what I got. Any questions?
Many thanks, Micah. It looks really, 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 really nice. I don't know if there are any questions from the attendees. Otherwise, maybe
maybe I could add, just for my own curiosity. Sorry, I cut somebody off.
Yes.
Yeah, honestly speaking, then when I can buy the no, funny question. Yeah, it's the PET machines in Poland are super rare. I would like to have one because it just looks great. Just in my eyes, this is the better times of the hardware design, of the computer design by Commodore. But yep.
Yeah, and this is one of their more interesting designs, and it was apparently this was what the PETs were originally going to be like, but the Commodore looked at it. They had this design done, and then they were like, no, that's too expensive, and we have a factory in Canada that can fold metal, so no. And that's why we got the metal 2001 PET shape, because they had a factory that made office furniture out of metal, and they wanted to use it, just Jack being cheap.
Yeah, the Jack way of making business as cheap as possible.
All right. Well, if there's no other questions, I think Sebastian.
Yes, I had one, maybe just because it's not clear for me. You mentioned at some point, okay, there will be some printing on demand. Do you plan to just post it on Amazon? Now you can have this printing on demand. Is that the way you plan to do, or is it something, because there you also mentioned manually created with the binding, etc. So it's something that you plan to distribute somehow, or how do you see the, let's say, distribution of this? Because indeed these computers are rare. It's difficult to find. Now you're building something that's really new. It's and that was missing. Let's not make this one also difficult to find, right?
Yeah, no, so like my first thing here is I want something for me, and so I've already been using it, and I'm happy, with the stuff I've written. But I want it to be anyone can get to it. So I'm gonna put it up on GitHub for one thing when I get like closer to done. Unfortunately, I didn't really think I was going down this path. I thought I was just making a little thing for me. So I made it in Apple Pages. So, whatever. But at least if I get hit by a bus, it'll be there. Yeah, I was planning originally to print them out myself, because I was like, there's like 5 people in the world who want this, right? So I'll just do 5. But I talked to like I said, I saw the Mega 65 one. I talked to the guy who made it, and I can't remember the name of the company. It's not Amazon, but there's a company that will do it. It'll look great. It'll have color printing, and they have distro in Europe and in the US. So, you won't have to like order it from the US and then wait 6 weeks and pay a bunch of extra tax on it. So I unfortunately I can't remember the name of the place, but it'll be there, right? And anyone will be able to download it as far as I can tell.
Okay, perfect. I'm just thinking that it may also be the starting point for other things, maybe someone else to taking over from there. But like when you're coding, you can have these in some editors. You can also have your customized code suggestion and these kind of things. Maybe that can be taken from there if the information is difficult to find somewhere else. Maybe, or maybe you would do it, or I don't know. There is a question posted there from Andreas. Will the book explain why the IEEE 488 on the CBM2 is not compatible with today's IEEE devices which work with PET?
Oh, if I could explain that, I'd be a happy critter. It seems to be that the only one I have is the SD to PET Plus. I think that's what it's called. And some things work and some things don't for me. So for me, the directory commands don't work. But if I use fmanager, my tool there, which doesn't use directory, uses just DOS commands, it all works. But I know I've got a person in Europe who says that with the same setup, well, something is different, but for him, it doesn't work. There's a different PET kind of SD to PET type thing, which I haven't tested yet, and I don't have a copy, but I want to get one. The best explanation I've heard is that maybe the ROMware for the PET to the SD to PET future is just not, it's a little buggy or something. I don't know. But part of the problem with the B machines is that the IEEE 488 port, the timings don't seem to be as lenient as they were in the PET. And there's some stuff where if you have a printer hooked up, you have to turn it on in a certain order or it doesn't start up, I mean, I don't know the reasons. I'm not a hardware guy. Sorry if I don't have a better answer.
Okay, no, thank you. I'm checking if there are other questions. If not, just one reflection maybe on the Phoenix that you took 3 years to receive. I think you did probably a good deal then, because three years ago with the inflation in the meantime, maybe if you paid 3 years ago and you receive it only now, it's probably a good deal when you see just the price of the chips and stuff like that, how they have increased in the last 3 years. So.
Wow, that's a good point. And also it switched from being a 3D plastic, like a PM, to be I got a resin version of it. So it's even better. Yeah, okay. It's a beautiful machine, by the way. I'm really excited. But it's bare metal, so I'm just gonna write everything. So that's also exciting.
Okay. Good. I don't see any more questions, but maybe people can post them in the chat. I don't know how much long you will stay in the call. Many thanks again, Micah. I will stop the recording now.
Yeah, awesome. Thank you.
And then the next one is Marc with the assembler in BASIC on the C64.
Okay. Hello, everybody.
Hello.
First of all, I have to share my screen, which is not yet possible. No, there's someone else doing.
Yeah, I think Mike, you need to stop sharing.
Yeah.
I think.
So I'm gonna apologize. I have not used Zoom in forever. We switched to something else. How do I stop this thing?
Yeah, this is perhaps somewhere where you have a share button. You should have and sharing, or maybe at the top. Maybe at the top of the screen there should be like a control panel. I don't know.
Okay, I think I got it.
I can probably also stop sharing, force you to stop sharing.
I think that did it.
Yeah, it's done. Okay, perfect. Now you can start. You can try, Marc.
Yes, I will share my entire screen. So, and now you should.
Yes, I can see your screen. By the way, the sound is not that good, at least on my side. I don't know for the others.
Maybe let my sound a little bit lower and higher. Is that better?
Not really. Do you have a microphone or something that you could use? Or
I-
headset or?
Yes, when I looked at it this afternoon, I saw that I can choose another microphone, but where was that? Installing audio. Yes, I can take the built-in audio. Is this better?
Oh, that's much better.
Okay.
That one is much better.
That's the other microphone. Okay, I'm going back now to my slides.
And I will start the recording.
Okay.
There you are, Marc. You can start.
Okay. Hello, everybody. Thank you for listening to me. I am Marc Dendo, and on the net I call myself Dendo, and this is the second part of a presentation I do. The first one was already in September 23, so it's more than a year. And I have a little project I'm doing, which I call Programming the Commodore 64 from Scratch. And, oh, that's not what I meant to do. Yes, so on that presentation in September 23, I presented myself and the what I want to do in this project. So I mentioned here a link to the YouTube come from Commodore Users Europe. And also I have a link here to my GitHub page where I have a directory with the software and also with the slides from 23 and the slides about the project. This is not the same GitHub page from last year because that one last year was about the compiler I wrote. Now I have done everything in one directory to because it belongs together. Okay, what I want to do in this project is in fact building an environment for the Commodore 64 without any existing tools. So I want to go back to 1983 where I got my first Commodore 64, and at that time I had no tools. I just got the basic, and if I wanted to write something in machine code I had to hand translate it and somehow poke it in. So that's what I do now. I just want to write tools in BASIC, in handwritten machine codes, and in the tools I already made in BASIC and handwritten machine codes. No, that's the game I'm playing. What was the first step last year? Well, I built an PL0 compiler. What's PL0? That's in fact the demo compiler. It's a very little compiler that was used by Niklaus Wirth in his book Compiler Construction. So I built this compiler in BASIC, and I showed it in September 23. And one of the last slides that I showed was the future. Then what would I want to do? That's cleaning up the code and write an educational text about it. I didn't do it. Extend PL0 to write PL0 in itself. So add some structures to extend PL0 in BASIC. That I did. Then write PL0 in itself. There's no longer in BASIC, but in PL0 with the intention to bootstrap the system. I didn't do that yet. I also wanted to make it faster because the compiler is very slow in compile time, but also in execution time because the compiler doesn't compile to 6502 code, but it compiles to an intermediate code called P code, and the P code is interpreted in a virtual machine. The virtual machine is also written in BASIC, so this is very slow. So I had the next step should be or writing the virtual machine in machine code, or eliminating the virtual machine and do code generation to 6502 code, or do something more exotic with some JITs or static compiler who compiles from P code to machine code. And then when I have that, I will further extend PL0 and write other tools. Well, what did I do? Not very much. I extended the compiler, which I call now PL0 extended, just like with it, with two things I need. That is print text, because the demo I gave last year, it was just integers I could use for input and output. Now there is static text, not something like string variables, but just static text to announce something on the screen, and arrays. And if I have time enough, I will give you a demo about this compiler after I showed you the assembler, which is the talk of today. So I decided of the three options to translate the virtual machine to machine code. So I have to write this virtual machine in handwritten, hand-translated machine code. And well, I started enthusiastically, but if you ever have done that, well, it's hard. And what's also a problem, the virtual machine, I need to change things because I want to grow it while changing PL0. For instance, I had to make changes already in the basic version to use the print text and to introduce arrays. Also, hand translating machine code is difficult to maintain because you have to work on paper. Well, I decided on a certain moment I'm going not doing that. I will use an assembler. But well, I don't want to use other tools, so I have to write an assembler in BASIC, and then I can use it only using the basic tools that I had in 1983. So I wrote an assembler in BASIC, and with the same IDs I used in PL0. That is, I will put everything in one file. So no editor for the assembly code. I will just put it in basic code with line numbers. So I don't need file IO, I don't need an editor, I just need one file. So it's very easy to develop and also to adjust and to debug, because I have only one file. Do I see an error? Well, I can change in the basic, and I can also change my program in assembly language in the same file. So test and debug the assembler. I can do. I'm sorry, I go too fast. What will be the future for now? Once I have translated this virtual machine in assembly language, will be testing and debugging the assembler while making that virtual machine for the compiler. So the testing will be the use of the program I want to make. And I will stop the presentation with the same 2 slides I used last year. That's everybody else is asking me, why do you do this? It's slow. It exists. There are compilers. There are assemblers. Well, because it's fun. It's because something I always wanted to do. It's the combination of my hobby and my former job, and I learn while doing it. There's a difference between reading a book about compilers and assemblers and actually writing one. You learn a lot, and I hope also to teach once it's finished by writing some educational texts about it. And I will end with the same remark I projected last year. It's a remark from Henri Bergson, which is a Nobel Prize winner in, I think, in literature, who says intelligence is the faculty of making artificial objects, especially tools to make tools. And that's in fact what I want to do. That is build some tools now to use to make other tools, and I do this on the Commodore 64, which is my hobby computer, one of my first computers I ever had. And yes, that's the game I played. That's what I want to do. So that's my presentation. I will now give a demonstration about the assembler, and if we have still time, await the latest version of the compiler. Okay. So, are you still hearing me and seeing me?
Yes.
Yes. And is this text? Can you read that?
We see the ED assembler 64 to pass blah blah blah. Yes.
Yes, it's readable.
Yes, absolutely. Yes.
Absolutely. Okay. So this is my program for the Commodore 64 for the assembler. Well, I'm not typing it in the Commodore 64. I think that's a little bit of masochistic. So I'm typing it in a real modern editor and then transfer it to the Commodore 64. And like I said, first line is a go-to for to the start of the assembler, and we have some space here to add an assembly language program, which is skipped by the basic, and then we have here our assembler. In fact, the assembler is maybe a little bit too long or too large, because I should have made a program who is smaller for demonstration purpose. I could have done every line in a string and then say the first 10 spaces are for a label, the next 5 spaces are for a mnemonic, and the rest is data. I could have done it that way, and it would be much more simpler. But since I had already written a parser for my PL0, well, it was not much work to adapt that parser to translate assembly language for the 6502. So for the demo here, I have a little program that will fill the screen of a Commodore 64 with stars. So it's a label assembler. It starts at the label start. What I do is the value, the ASCII value of a star, an asterisk, loading in the A register, 0 in the X register, decrement it, and then on address hexadecimal 400, 500, 600, 700 indexed by X, add the star, and loop until X reaches 0 again. This is, I think, the most fast method to fill a Commodore 64 screen with stars. So it's a very small program, but yes, like I said, it's a basic assembler, so it's not very fast. Okay, I will now start Vice. I'm using Vice as an emulator, and I'm now injecting this basic code, and we're starting. So it's a 2-pass assembler. So it will pass the first time, it will scan the code to calculate the values of the labels. So you see, it's slow. And now we're going to pass 2, and it's going really to generate code into the memory of the Commodore 64. Well, it's done. So now I can execute it. The program is default set on address C000 hexadecimal, but I can change it because I can add an org command in the assembly language to make different parts of the code. And there you see the program worked. So I think I have a little bit time for showing the PL0 extended compiler. It's so, like I said, the same principle. I jump to the compiler, who is starting here, and here I have a program written in PL0, which is a very small version of Pascal. So what I'm doing is I define a constant, a variable which is an array, a procedure store, which just calculates the squares from E in that array, a procedure display who does the inverse and will put them on the screen. So the difference with the demonstration of last year is that there are arrays used and that I have the possibility to show static text on the screen. So the exclamation mark is the equivalent of print in Commodore 64 BASIC. So print something on the screen. So I will start it. So, and this is a larger program. It will take a little bit more time, but on the other hand, well, it's only a 1-pass compiler, so it only will be treated once, so it won't take that much time. But of course, it's very it's not very fast, but the moment I have changed the virtual machine to assembly, the execution will be faster, and then I will rewrite the program in PL0, which I can compile at that moment, and then everything will be very much faster. So it's done in, I have generated 194 instructions, P code instructions in approximately 1 minute. Now he's executing. So he's executing P code also in that virtual machine, which is still in BASIC. Like you see, there is room for optimization. He's printing character by character. So what I could do is store somewhere the string and then use a routine to print it in once. So there is a lot of room for optimization. And like you see, that's the output of the PL0 program. It announces the two procedures it entered, and then it calculated the square from 1 to 4. And it did that in 50 seconds, which is, of course, a lot. So that's what I've done. That is the state of the project for the moment. I'm not working continuously to it. It's well, it's a hobby project. So that's it. Thank you for listening. And if you have any questions, I will be glad to answer them.
Hey, thanks, Marc. That's super nice. I think when I look at all the same in this virtual machine, the PL, the editor, the assembler, the interpreter, you have produced more tools than Commodore themselves. Making that available for everyone is better than what they've been doing. I was just, so there was a question, but I think this was answered with the demo. Can you show example what the mixed basic assembler code look like? So I think that has been answered.
I think it was addressed. I have one question. I don't know, maybe you said that at the beginning. Was this technique actually used back times? Because I know that for the initial coding of the software for the new computers, they just use cross compilers, even for some mini computers. And I mean, this technique is quite impressive. You can implement faster assembler using the slow assembler, and you can go on. Yeah, was it actually used by somebody?
I don't think so. I think at the time, end of the 70s, begin 80s, that they used, like you said, cross compiling. But what I want to do here, in fact, I was 18 years old when I had that computer, and I wanted to create my own software, but I didn't have the time, and I didn't have the knowledge to do that at that time. Now I studied computer science. I know how to do that, and now I want to get back to what I could have done in 1983 if I had that knowledge at that time. But I'm, like you said, I'm sure that the real software houses at that time used cross-compiling, yes.
I read once, because there was this KIM-1 computer that was the very first MOS1 computer, the demo board or something like Arduino for the MOS CPU, the demo stuff, and it was actually like a demonstration tool, and somebody has ported a BASIC into it, so the engineers could actually type something. So So this is a kind of this approach, even if I don't know how they did it. Maybe they just crafted the assembly language on a paper, maybe, but it is also some kind of similar approach.
Well, the really first computers in the 60s and begin 70s, when they had no means of compilation, they had to be bootstrapped with switches. So once the really first programs had to be made by that, but I think end of the 70s, begin 80s, it's cross-compiling. I'm quite sure of it.
Micah has posted a few good reference to further read also about machine language assembler that worked a bit similar. Maybe something good to read afterward. I don't know if there are any more questions from the attendees. Apparently not. Otherwise, you can maybe post them as usual in the chat. Many thanks again, Marc. Really
Thank
nice.
you very much for listening.
I will stop the recording now. Trying to do so. Yes. And then we can call the next Marc, Marco.
Yeah, I'm here.
Yes, perfect. With UG or micro G basic, you will explain. Let me just start the recording as well. Floor is yours, Marco.
Thank you. I am going to share my presentation. I hope it shows something.
Yes, you can see.
Okay. Just start. Okay. So, thank you. Sorry. Okay, so thank you for the opportunity of describe my project. I am Marco Spedaletti and I am the author of ugBASIC. First of all, the name should be pronounced as ugBASIC with a soft G. Okay. The letter U stands for micro because it is a minimal language which is translated as linearly as possible into assembly without abstractions. Okay. And the letter G stands for game because the language was designed to write video games, even advanced one. Okay. Anyway, ugBASIC is an open source, isomorphic, modern basic, and cross compiler designed to easily develop portable programs without sacrificing efficiency. Okay. It starts or tries to start from a single source to create programs, basically video games, for various 8-bit computers. Before going further and explaining what hardware is supported, I would like to dwell on the concept of isomorphisms. Everything started a few years ago when I discovered that I could program in C language on 8-bit computers, specifically the Commodore 64. It had always been my dream to be able to do it when I learned the C language, obviously. So I started writing some games with the C language, obviously a library of common user functions. Since the C language is by its nature portable, I started to create a library that would allow the same game to run on different computers. Is an example on M6 and ZX Spectrum, even on different CPUs. Here I run into a number of limitations of modern languages when used on 8-bit systems. Wanting to create something portable but at the same time efficient, I invented a new programming paradigm that I called isomorphism. Okay, the mathematical definition of isomorphism is clear enough. We are in the presence of an isomorphism when we can make the elements of two equivalent sets correspond to each other. In this context, we do the same. We match the parts of the computer to each other in the best way for each supported hardware. The rationale of this choice is that, even with many differences between them, the hardware design in the 80s started from similar concepts and was realized in similar ways. You could almost speak of a sort of evolutionary convergence. So the goal is to achieve a form of efficient portability, something that I had not been able to achieve with the modern languages. Portability because I would like to be able to port a game written on one computer to another with minimal or any changes. Efficient because I would like to that the fact of having a game on different computers does not mean that the game works well on one computer and badly on another, or even in a different way, for example, changing the gameplay. Okay. In short, the goal is to not introduce unnecessary abstractions. This is a brief comparison between approaches. On the left, we have the traditional approach. The language gives access to a library that abstracts the computer, and then each computer has its own implementation of the library. In this case, there are no sprites in the library because only the Commodore 64 has them. The abstract computer misses them. Okay. On the right, we have the isomorphic approach. The language gives direct access to the hardware characteristics if present. So the isomorphic approach is pragmatic. In fact, the isomorphic approach recognizes that there might be a correspondence between features, but they may be implemented differently, or that may not even exist, and it makes no sense to try to introduce them with an abstraction. Okay. To better explain how an isomorphic approach is, I showed that in this diagram that not all features are available everywhere on each target. Okay, so there is bitmap graphics is not available on VIC-2020, the Commodore VIC-20, and for example, sprites are not available outside the Commodore 64 in this case, and so on. Basically, the language tried to resolve all hardware-dependent values and parameters at compile time. By not introducing abstraction, we are able to give access to the programmer to values and parameters that are related directly to the actual hardware. They are not translated at runtime, they are not in a sort of abstract form, they can be used directly, okay, by the programmer. For example, in terms of color management, ugBASIC directly encodes colors as values. The color red is specified with the keyboard red. Shades of red can be specified at compile time with the RGB function. The compiler itself converts images when generating the executable, and therefore also shades of red. Or you can use directly the value 2, which in the VIC-2 chipset indicates the color red. As you can see, in all the cases shown in these slides, there is no runtime calculation. Everything is solved at compile time. Okay, but what about the color command of the classic BASIC, the one that changed the register, like in fact the registers of the VIC-2? If you use this command, you are assuming that there are registers to configure and a programmable palette. So, if there are programmable registers, ugBASIC will let you stamp them. Otherwise, the command will be simply ignored. This is another important sample of isomorphism. If the hardware is not present or is not capable of that functionality, the compilation does not stop and the command will do nothing. Another sample, okay, maybe it seems like a strong statement, okay, but all modern languages use stack to pass parameters or define local variables. This is a problem because on many 8-bit processors, the stack is slow, inefficient, and somewhat inconvenient. It introduces a big slowdown in use. The isomorphic solution is to do without it. So ugBASIC is, in practice, a language without a stack. To make a long story short, The language provides a series of features that each target then implement in the best way. The reason I abandoned C was because with the C library, once the isomorphic approach was implemented, you're no longer programming in C. In practice, there was no longer a distinction between library and language, so it has no sense to continue to use C. In other words, the distinction between language intended as syntax and semantics and libraries is another factor of inefficiency on 8-bit computers. BASIC, which was born without this kind of distinction, is therefore the IDA language. In summary, ugBASIC produces executables for more than 20 on computers and consoles, but as a language without abstractions, it does not guarantee the result will be the same everywhere. However, we know that what runs will run well, and this is a significant improvement. So this is the actually supported hardware. Okay, we have 3 different processors and many models, many targets on computer and consoles. So the compiler, which is actually a cross compiler, runs on Linux and Windows and produces assembly code and executable for all this hardware. In particular, these are the Commodore targets. Note that ugBASIC also handles the Zilog Z80 processor inside the Commodore 128, and also the RIU memory expansion, which ugBASIC treats as a real coprocessor. Okay, so now let's take a look at what are the features of ugBASIC. I tried to summarize some of them, but obviously there are many more. Okay. For example, we have easy rapid development, console support, fast and easy animations, built-in support, multiplex sprites, input-output controls, dynamic strings, suspension memory management, inline assembly, native multitasking, and it's all open source. This is a feature for me. Okay. Now, first of all, ugBASIC is able to convert images from modern formats directly into the most efficient native formats for the select target, which can be, in the case of the Commodore, the VIC-1, the VIC-2, the TED, the VDC, okay? This obviously speeds up development and allows to port programs easily and to use modern tools for graphic drawing and composition. The drawing routines are optimized and easy to use both for implementing rapid animations and for managing structured frames such as atlases and sequences. So you can draw frames and let ugBASIC draw them for you. For the VIC-2, it's possible to load images and use them as arrow sprites or even composite sprites, one over another, to increase the bit depth, the core depth. If multiplex sprites are used, the image will be automatically converted into a set of sprites that will move all together to have a bigger sprites. For the VIC-2, it's possible to define up to 32 multiplex sprites by using specific characteristics of the hardware. Okay, so it's out of the box. As we mentioned before, the RIU memory expansion is managed as a real coprocessor. Therefore, all copy operations exploit its potential, including those related to the driving of graphic resources, which can be hosted directly on the memory expansion with the simple primitives. I make you look at an example. This is an example of expansion memory management. In this case, we are running a video synchronized with the audio. Obviously, you can't listen to the audio, but I'm sure you could listen to it. Reading frame by frame and drawing them on the screen. Currently, this animation is made with this small program. This program uses a set of primitives that are enabled on the Commodore 64 when RAM expansion is installed. The compiler has strong optimization, particularly it's a two optimization mechanism. The contextual optimization, which analyzes the basic source to make space and time improvements, and the people optimization, which instead focuses on the generated assembly code. The language implements a very efficient multitasking based on proto threads capable of executing dozens of threads at the same time and without using interrupts. This technique is used, for example, to implement unattended animations and movements and independent logic of the MPC and so on. Assembly can also be used directly in line in the ugBASIC source. It supports both single instructions or interface of code. Note that it is still possible to write portable programs as it's possible to specify the target CPU. Okay. The compiler is completely open source and it is distributed under the ugBASIC license 2.0. This allows you to modify, distribute, and sublicense the original code. The repository is located on GitHub. This is also a very large user manual of almost 1,000 pages, which introduces the various features and display how to use each individual command of the language. Since the language is constantly evolving with frequent releases, the manual is updated every 10 days or so, so it's worth keeping up to date. Now, let's see how you can build a game. You can use the command line on both Linux and Windows to generate assembly code only. So what you do is you write your basic source, prepare your graphics, sounds, and so on. Then call the compiler specific to the target you want. Here, for example, we are talking about the Commodore 64 and the Commodore 128 with the options you want. In this case, it's up to the programmer to use the assembler and linker to generate the executable, actually a single PRG file. This is the list of the Commodore targets that can be used to compile the program in BASIC. Obviously, there are also non-Commodore targets. There are 20 targets, if I remember correctly. Anyway, if you want, you can delegate the task of calling the assembler and the linker to the compiler. Both must be reachable by the ugBASIC compiler. This is actually the only way to automatically generate ready-made media such as disk images or REU images for emulator. This is very useful way to test your program without waiting for loading the REU, the disk into the REU image in the REU memory. Finally, if you are on Windows, the easiest way is to use the EDI. In this case, compiling and running the game is a matter of just one click. Okay. The EDI is a free tool that takes care of simplifying all the phases from the preparation of the development environment to the actual development. It also gives access to the online help and takes care of managing the versioning of the compilers through the use of the scale time machine. And finally, gives access to an online help that contains the same information as the manual. Here we see an example of programming with the EDI. It is a window that shows the single source code. Here on the right, left is the source. On the right, we see the various graphics resources that, for some targets, have been customized to be more suitable for characteristics of the video chipset. By compiling this, which is a single source code, for multiple targets, you get games that are similar to each other, but from a single source. Now, let's go over some technical details. Okay, don't worry, I won't go into too much detail. It's just to give you an idea of the complexity of the project and also its potential. The workflow is pretty straightforward. It starts with a one-pass compiler specific to that target, which is built using standard tools like Bison and Flex. There are no dependencies on system rooms, or at least there are only when the program is booted. The compiler generates assembly code directly. There are no runtime modules, and it accesses the hardware directly. It also collects all the data it needs in the same executable. with the exception, obviously, of the data stored on the memory expansion that is stored apart and loaded during the startup. This is a typical schema of generation. The compiler essentially generates assembly code and data. Note that this representation may be different depending on the target because the data can be interleaved with the code. As mentioned, the compiler primarily produces assembly code, converting basic primitives and instructions directly. It is possible that some routines can be quite complex and therefore they are written as real libraries. The libraries are included directly in the code flow. Some instructions are written in a sort of pseudo-assembly that is called the median language, which run on all targets without distinction of CPU. Note that this is not an interpretation mechanism, as the median language is also converted directly into machine language. Everything that is generated is subject to a series of optimization mechanisms. These processes are very effective because the code does not use the stack and can therefore be statically analyzed. The data is compressed by proprietary algorithms such as the MCS1, that is an algorithm of mine that's similar to Lamperziv4, or the more classic RLA. ugBASIC is made of 400,000 lines of code. Okay, about 64% is ANSYS code that generates directly assembly. About 20% is code written directly in assembly of the target machine. The rest is the parser that examines the basic source and coordinates everything. The ugBASIC itself is a language that has 693 keywords with something like 657 commands. The Commodore targets are the ones that support them in the greatest number and most completely. Let's take a look at some games written with ugBASIC. Note that this is not a successive list because I am not always present with them. Okay. However, for those games for which I am able to obtain the source, I try to ensure backwards compatibility for future developments. Creepy Carrots show the capabilities of ugBASIC for the Olivetti Pods PC128. It has bitmap graphics, video page switching, double buffer, 3-bank RAM management, and inline assembly. It is also an example of all the language, despite being able to work on multiple targets, it is also efficient on a single one. Then, The Savage Sword of Cocoon is a fighting game in the vein of Barbarian for the TRS-8 Core Computer 1.2. In this case, the optimizers have done a great job rendering the animation in real time and full screen. Sogo 64 is a version of the puzzle video game, and it is also an example of how portable video games can be written for dozens of different targets. In fact, the original game was written for the Commodore 64 and then adapted by me for almost all targets of the ugBASIC. Acme Incorporated is an arcade game where multitasking is used to move the barrels and the character. This game entered the contest of basing programs written in just 10 lines or less of code, graphic included. Falling Balls is a multitasking arcade game for one player. The player must make the balls fall into the basket in the bottom of the screen in the shortest possible path. This also entered the 10-liner contest competition. For Gravity is a game it's a clone of Connect 4. The goal of the game is to be the first to form a horizontal, vertical, or diagonal line of 4 of your pieces. Obviously, this is a game that runs on Commodore platform. Finally, Pick the Star is another single-player multitasking arcade game, and also this one is a game that joined the 10-liners competition, and it also ran on Commodore target. Finally, the language has an official Facebook group, a forum, bug and project tracking, and it is also present on Discord server for specific targets. Okay, thank you for watching. I finished my presentation in 22 minutes.
So you are very on that. So you are the one with the Swiss clock then. Good. No, many thanks, Marco. Very, very impressive. Yeah, I had a few questions before the presentation, but you answered most of these.
Yeah.
One thing, yeah, and you know, of course, that because we've been exchanging before this event, so you know that I was looking at the manual, which is really nicely done, because actually I plan to play a little bit with the language during the holidays, so I started already setting up a little bit. For that, I was just wondering, specifically for the target 128, because then you can generate there the code for either the 65 or the Z80. What would be did you make an example, or do you have any example just to see what's the rendering, how different it is from one to the other? Because I think
I could make a bit, I think a bit demo sharing the EDI compiling on the fly. So this is just an example more of that. Just a moment, I try to.
Okay, because
share.
that's very interesting in the sense that, you know, this computer is a bit special for just for that, because it has, they wanted to keep this cross compatibility with the 64, but on the other hand you have this Z80 processor on it, but in the end it was mostly used as a C64, and apart maybe with what's his name, that name, not the DOS, but you know, this other system that was used in that was using the Z80 for maybe more professional applications. The use of the Z80 was really, I think it was underused. But the capabilities on graphics, for example, was supposed to be much better, and we it's not something that you see so often, to have the same. You could have some source code that
obviously the classic hello world, okay, is the classic hello world that makes gives a feedback on the simplicity of the system, the easiness. If you run on the Commodore 64, okay, pardon, Commodore 188, we have the two alternatives, MOS and the Zilog. Okay. If I try to MOS, obviously the demo effect, hello world, here we are. Okay, it was expected. Okay, and now run Commodore 64 on Zilog Z8. Obviously, in this case, the output is the VCI, this one.
Yeah. Okay.
Okay.
I would be more but okay. I will play probably with this during the holidays as well. As just to see how, you know, more for graphical thing.
Yeah. I can. Okay. I can try to with on an example.
If you have one example, don't start building something completely new. But if you have something available.
Yeah. I have the sample. For example, drawing. I think I have speech graphic primitives. No, excuse me, some contributions. This is more interesting.
Some
other contributions. Nabu, Starfighter, for example.
Oh.
Open. And I have to, just a moment, I have to take from the GitHub the file. That's just, I was not prepared. Just a moment, I have to prepare the sharing.
Okay.
So I have a more complete set of information. I use I have some automatic building system in order to give to every developer a specific environment for its easiness, because not all developers have the same configuration. Some use Macintosh, some use PC, some use 32 bits, other 64 bits. So there is an automatic building system that helps me to make everything aligned. Okay, So I am going to boot this one. So I am able to open the samples in the very complex example this time. Just it's okay. It's ready. Just a moment. I am.
Yeah.
You need to
I was
share,
just
yeah.
thinking one thing when,
Yeah, I
when you
have
were
to
showing
share.
this,
Yes, yes.
when
Okay,
you
the
were showing this
examples.
animation, I was thinking
Why?
that you had just invented the GIF for the GIF for C64. It was a bit.
Okay, I am trying to share the screen. I
Yeah.
hope something is visible.
Could
Now I take, for example, the contrib Nabu. I'm going to test with you. It's
Okay.
demo effect Nabu. Okay, run on Commodore 28.0. Yeah, completion. Okay, you like it? It's drawing
Yeah, I can see.
Nabu Starship without scaling. This is the version without scaling.
Yeah.
The system, the ugBASIC gives access to primitives that do auto scaling and is able to do something interesting in this way. But obviously, scaling means slowness. And this is the price. And it's better to have a pre-calculated file. And then you can do it because ugBASIC allows you to specialize files that are used for a single target. In fact, you use the command load, okay? That is a way to initialize the content of an array. This is one of the many ways to do this thing. It's not the only way, but it's just one. This command means it's basic. It means create an array populated with the data inside the contrib Nabu text. This is a sort of CSV as text. So ugBASIC parse it as a text as a CSV. The read-only is useless on Commodore 6128. It is an isomorphic keyword, okay? But it's very useful, for example, for ColecoVision, because ColecoVision has very little memory. So you are suggesting to use this the ROM to store the data. This is unchanged data. So you see, this is a Commodore, this is a ColecoVision. Okay, the very same source runs on Commodore 64, on Commodore 128 using Zlog and ColecoVision Zlog, but they are the very different video hardware and very different way to access to the hardware. This is an example of isomorphic approach. Okay, so actually you are able to specialize and to write just one source and to get access. For example, the example you say you saw before with the deft is done by writing just one and leaving ugBASIC find out the mode to do it in the best way. Obviously, it doesn't mean that it's what you expect, but surely it's something very interesting. For example, the game I make you see the Soco Plus, the game is written. This is just one code. Okay, this is not. There are no conditional compilation. Just in one, for example, this is a way to initialize an array. Okay, as you can see, we are storing 2,304 bytes. Actually, ugBASIC take the ownership of the PC, not the Commodore 64 in this case, and make all the RAM memory available. So you have almost 558 kilobytes of memory that you can use as you want. You can use to storing data, to storing videos, storing what you want. And this is an advantage because you can use easy tools to driving graphics. You have not to worry about the memory, okay, because ugBASIC manage it. Also, you have also it's a bit difficult to show you, but it also has the management of dynamic strings in with a garbage collection that is constant time. And this is a very interesting implementation because it can be used for video games, because strings are something that is normally very slow, very not very useful on real-time video games. Instead, they could have a role in ugBASIC, because ugBASIC give you the opportunity of use them and don't worry about their weight in terms of computation power. As you can see, this is the only the only actual conditional compilation. Okay, this process will not generate code. Its joystick is not available. This is the only
Condition. Yeah.
condition of the program, because I was interested in give access to this game also on the target that has no joystick.
Yeah.
And there are targets with on joystick. For example, Olivetti products PC100 has no joystick, or also Dragon has no joystick. They are joystick, but the analogic joystick is not very is not very stable. So you with the ugBASIC is the IDE, and they give you, for example, access to the manual. You just press F11, I give you the explanation. You can also view on the web if you want. So you have access to description, okay? And you also can ask on forum. You can
nice.
also have an help. And this is very useful for, and time you can earn time by using the system, because you have you can be helped in developer, and obviously you can access always on the last version, because you have access to also obviously to a wizard that help you to see if there are compilers that are being updated. In this case, no, because it's just updated. And obviously you can access directly on each single compiler, and you can refresh if you want. You can download it, and the system automatically download the correct version and help you to avoid to have, for example, imagine you are developing a program, okay, and you find out a bug, okay, then I will correct the bug, and you will be able to update automatically and without problems to your compiler directly from the same interface, and continue to develop without never leave the IDE. I think this is a very interesting feature.
It is very, but let's not diverge into a presentation on the IDE, even though it's very interesting.
Yeah.
I will check if I see a lot of comments. Impressive, great work. I don't know if there are any more questions from the attendees.
Just wanted to add that I like very much how it starts in Z80 mode, because it goes directly there without using CPM.
Yeah.
Just load and run.
Cool. Yeah. The ugBASIC take the ownership of the Zilog Z8 by using obviously 600.502 code. So there is a sort of preamble that makes the Zilog Z8 available.
CPM, that's the system I was looking. I mentioned DOS, but I was thinking CPM. Yeah. Good. Any other questions or comments? Otherwise, you can post it in the chat. I think looking at the time, we need to switch. Many thanks, Marco. Very impressive. I will have fun during.
Thank you. Thank you for watching and for listening.
I will stop the recording now. And then now we've looked at how to build games, but now we will look at a nice game written by Maciej, are you still with us? I hope so.
Yeah, I am.
Okay. Now we can see Tony. Just give me 1 second. I will also start the recording for you.
Okay, you can see my screen, I presume.
I can see your screen.
Great.
Yes.
I'll set up my
Recording
timer.
has started, so you can
Yeah.
start.
I must admit, I really regret I'm last one because it will be very hard to impress you guys, honestly speaking. I wasn't prepared for this kind of high quality content today. Sorry I doubted in you, but I was so amazed by everything I saw today. You're making great things. So I just made a game, actually a Commodore 64 version, because the game creator gets crazy and he is porting it to every existing platform actually. But I'm responsible for Commodore 64 version. The game is called Tony Montezuma's Gold, as you can see. And let's say the publisher was called Monochrome Production because the game was 1-bit or monochromatic on purpose. But it's no longer a case because just a week ago I have published a free update which added the colors to the game, because there was like a half of the users were complaining there is no colors, and half of the users said don't add colors, please. You'll break everything. So now you have actually a choice. Yeah, you can choose. Yeah, I have spilled my water. Now that's a bad thing. Okay. I need a little. Sorry for a moment. This shouldn't happen. Okay. So first, introduce myself. I'm Maciej Witkowiak from Poland, and this is where I was born. I got my first C64 in 1990. As I said, that was the time that actually we could afford to buy one. That was already outdated machine, therefore we could afford to buy one. And I almost instantly wanted to become a programmer and start coding video games. The history went slightly difficult, so I became a professional programmer, of course, but I was just making business apps, and I'm specialist in Java, TypeScript, Kotlin, a bit of Python. Why? You can actually make more money with this. Honestly speaking, I'm making video games, even though in Poland we have a few great video games companies. And basically 2016 I got my second Commodore 64, and I went very deep into retro thingies, and I started to write some code. At that point of time, it took a while to publish something, I would say, significant. There is a QR code, you can grab it for my GitHub account. It's a bit of stuff there, maybe not that many. And as you see, I'm also coding assembly. That's 6502 assembly off time after work. I went so high level at my work, so I was mostly coding assembly the first half of this year, honestly speaking. I haven't coded anything else, maybe except Python. So, as I said, I wanted to write a video game, and I had a plan to write a video game which will be like a monumental. So I wanted full scroller, the Turrican class or Metal Warrior, and I even started, and I even published T-Rex 64 Endless Runner game, which has a scrolling screen side, like the easiest thing you can do with the scroll. But then I just entered one of the forums, that the Polish forum, C64 scene, and the guy just wrote, I have a game, I'm looking for a coder for Commodore 64. And I looked at the game, it was like a black and white flipped screen game. I said, I don't want to write on the flip screen games. It's really no challenge, but I said, okay, it's 3 months of work. Yeah, graphics looks great, so perhaps somebody will notice. So I took it. Yeah, I took this job, and after 1 year of working, I have published this. which is the monochromatic version of the Tony game. It's flip screen game. I added a little bit of flavor just to be better than Atari, because the game was originally planned for Atari. Therefore, it is monochromatic, because on Atari, the standard Atari, you can have a high-res mode with just two luminance of the same chroma. I just added these highlights on a dashboard to be a little bit, to show that, we can display more, but if we wanted, we could display more. So the game is pretty standard, except that it has a very detailed high-res graphics. And honestly, that was the only reason I took this job, because I thought that it has a potential. As you also see, the animation is quite sophisticated, so to say. And yeah, this is the timeline. So it took 1.5 years of my life to just end up, and I finished last week to release the full color version. And this is only the names of the people that are involved in Commodore 64 version. So it's Rafał Dudek who made the graphic and designed the game. We had two great musicians like Sami Juntunen and Adam Gilmore agreed to compose the music for us. It's actually quite known from gaming. And a lot of testers at a different stage of the project, the different people helped us to test the game, because the game is like 5 levels and 145 rooms. It's a lot to test, and there was a lot of bugs found, and sadly we have to correct some of them because some bugs have been sneaked into. So this is quite big project, even if I look from my professional perspective, if you consider just a single person coding, because the projects I'm normally working like 8, 10, 100 people working on, and it's millions lines of code. This is of course not that big, but it's just a single person who does the coding. And there were some challenges in this game. Therefore, it took me so long to implement it, even though I have thought it's trivial to implement. The amount of animation, just I took the job. The guy Rafał started to send me the specifications, and I looked, oh shit, how are I going to do this? I mean, it's not going to be that simple. Even at one point of time, I was seriously considering using the bitmap mode for this, because I said there's no way I can put that many animations into the single screen. Of course, the memory was the major limiting factor, and I had only 256 characters to use to build the screen if I would like to choose the text mode, which is quite good, because on Atari 800 they have only half of that amount. So the decoder for Atari, he had a really hard time. And the time pressure. So because I'm coding this for somebody else, there is a time pressure. So my advice is never do this. Always do after work, hobby work only for yourself. Yeah. After some, let's say, trials, I decided to use the standard high-res text mode of Commodore 64, because I decided that I will be able to handle all those animations with combined sprites and character graphics. And basically you see what is done how. And there is also a screen split in the middle, so I render the dashboard using different hardset. And again, as I said, another problem was I would like to use the background animations, so I need to reserve some space in the hardset. And Rafał made some of the levels using all 256 characters. Yeah. So how I'm going to do this? And then somebody told me, it's globally used in the level, but is it really the case in a single room? Yeah. So I said, okay, let's try it. And apparently I just used this hardset crunching technique. I have just invented this term yesterday when I was making this presentation. And I'm just rebuilding the hardset for each room when I'm entering the new room. I'm rebuilding this completely, and I'm putting in the free place the extra characters that I need to use to do some animation. And I was thinking this will take a lot of time, but apparently not really. It's really fast. Yeah, so this is one thing. The second thing is that the levels are huge, and they, of course, do not fit into the memory without any compression. Originally, I have just used the running length encoding, but it wasn't very big. But at some point of time, I decided, okay, I had to start Exomizer, the cruncher, to make everything fit for the demo version that was the single file game. And then I saw, okay, if I will just use it to compress every single room. And I did so, and it works. So each time I change the room, I have to decrunch the room from the memory to the screen. I have to rebuild the character set. And now in a colorful version, I need to repaint it for different colors. How long can it take? And I will show you that later. It's really, really fast, to my surprise. Character animation. This is the thing which actually make this project possible. Yeah. And as you see, I'm animating quite a lot of stuff on the screen. And the most impressive are all those moving stones that are, moving from that's the stone traps. And I just made it in a way that I have 8 different phases in the code. Each phase is executed for each frame. And basically each phase is responsible for animating something. So like phase 1 is animating the flames in a potion. The phase number 2 is animating snakes. Or this spider, it has the left and right orientation. Normally when you jump over, it turns to another side. So we need 2 different set of characters and 2 different set of animations. Those spikes, deadly pikes here, that are also animated with a hard set. I don't know, I think I support up to 8 different pikes on a single screen. And the stones, originally we had 3 stones, but I have discovered I can put I can double this without sacrificing the frame rate. So I just reworked this level and it supports like 6 moving stones, just because I could, not because this is a nice level design, but I just did it. And if you look here at this little screen, this is how much raster time I'm using, and this is the music. This is the game logic that, for my convenience and because I'm lazy, is running completely synchronized with the screen. So at 5 hertz, 50 hertz, or 60 hertz, depending the PAL or NTSC. But by the way, this games works on both NTSC models. The raster time wasn't the problem here. And the animation, everything on the screen is just done here off screen. Yeah, therefore everything looks nice. And basically, this is how it works. So you see those moving stones. Really like this effect. Yeah, it's kind of impressive. And well, yeah, there are sprites flying on. And then you will also see the how much time is needed to repaint the screen. So honestly speaking, not much. The fade in, fade out takes more time than actually repaint the compress the time. Okay, no challenges in raster time. It was easy peasy. No sprites limits. No sprite multiplexing was necessary. Yeah. Disk version, I never did it. Somebody recommended. I think that was Jaskat. Recommended me to use Cadaver's fast loader, and it was great choice. Cartridge version for Magic Desk format, it was apparently very easy. And as I said, the room decrunching very fast. Yeah, so saved a lot of memory just to do this. And yeah, just to finalize, I just decided to do the color version. This should be there from the beginning, but because of the time pressure, I wasn't able to put it into the premiere of the game. That was, I would say, June this year. There was very high demand to make this color version. I mean, I knew that in the high-res I could put all the 16 colors. I made a little proof of concept. We liked the effect. There was no impact on performance at all, because basically for Commodore 64, it doesn't really matter how many colors you display. And I just needed a little bit extra memory for code and color map. And because I think this monochromatic version, I had like a 63 bytes left for code. So I had to do some further optimization. And basically this is the color version, yeah, that I have just been. This is almost the same backdrops. I just applied the color. It took me a while to do some experiments, and took even more to make this tiny Tony's character look like this. And I would say I had to limit myself, because I noticed that I shouldn't be very generous with the different colors to make it look sort of consistent and nice. So I only put some additional shades on the key or on this jewel or those stones. But besides of that, like the bricks are like a monochromatic. And I think that the effect is quite decent, so to say. And also another challenge, and by the way, the graphician just told me, do the colors for this platform. I have no idea about the limitations, so you will do the best. So the colors is actually my work here. And I also did whatever I could to make each and every of those 5 players to look distinctive. Yeah. So for instance, I ended up with some surprising white color in the pyramid. I think it looks nice, because I just didn't want to repeat myself. Yeah. Just I'm about to finish. I'm actually quite good with the timing. There was some additional challenges in the color version. I have noticed that also with the monochromatic version, you can change the color from the default black and white to some other schemes by pressing F1 button. And some of the colors, like a blue or green, had those jailbar effects, very ugly jailbar effects, especially in the first level. And it is because Rafał used the chessboard pattern here on this shadow that you see on the sky. And this is the reason. I mean, you have to be very careful with high-res graphics, especially on Commodore 64 VIC-2, because it is a bit shitty to render it on a screen, especially on a real CRT. Technically, the VIC-2 is not able to, to raise the Luma level fast enough and then to slow it down. So the single pixels on some monitors can be simply not visible. And sometimes they tend to change the color. You have a color artifacts. And now it is, of course, combined with this typical J-bar effects that we see in a Commodore 64 if you plug it to the LCD display, for instance. So, I mean, I did some experiments and I decided just to replace those chessboard pattern with some horizontal bars. Basically looks very similar, but as you see on the right side, the ugly effect is gone. And if you look below, actually, this is something I was kind of happy. You see these bricks and the ladders, they are only using 2 colors, plus black color on the background. But because of the color artifacting, it actually looks quite colorful. So I leave it. And yeah, my next productions, when I will decide to use high-res, I will try to use more this color artifacting. It's very interesting thingy. Yeah, this is something I did last, and I was almost. It was very frustrating because at the first I thought that this black outline on the main sprite will not work well over the black backdrop. So I have experimented with the several different colors. All was shitty, as you say, failed attempts. So then I tried with I look at the Rick Dangerous main sprite, and I say, okay, they use the black outline. Let's try the black light outline, and this is how it looks. Yeah. So you see how many different frames we have. It's consuming a lot of the VIC bank. And basically the main character is 2 high-res outline and 1 Y-stretched multicolor sprite. And that was, of course, also for the mono version, although the multicolor was then all black. If you just to address some of the questions, I coded everything in assembly using Kick Assembler, Exomizer, cover bit obsolder system. I'm a big fan of Hardpad Pro, SpritePad Pro, so this is what I use. Retro Debugger, great tool. So this is all I used. And basically, this is everything. I'm super time boxed. This is my second name, time boxed Maciej. This is our web page with a game. We have a publishers. We even have a box edition. This one is for Atari. Yeah, would like to. The color version will be released by this NRG. It's Nocne Retrogranie in Polish, and they made some very, very, very nice limited edition. But you can also grab a digital version if you are not a game collector. I will publish this presentation on my GitHub page. You had the QR code earlier, just in case for some reason you need it. But there will be video recorded soon. So to say, okay, thank you. That's all I have. Sebastian, you are muted. We cannot hear you.
Indeed, yes, thank you. I was muted software, but also hardware. No, many thanks, Maciej. I had actually a couple of questions, but then you did answer them. It was about the performance. I was not expecting to have indeed something, you know, the Commodore, you have some memory that is available, and then you fill it or you don't. So it's not normally not.
From the three original ports like Atari 800, Amiga 500, and Commodore 64, the Commodore 64 is the most performant version. Don't ask me why. But it's written purely in assembly, and the Amiga version is written in ugBASIC and compiled. Yeah, so it's that makes the difference actually.
Okay. I don't know if I don't see any question posted in the chat, so at least on Zoom, I don't know if attendees have any questions. If so, then just unmute yourself and ask the question. Maybe
well,
you could just...
Maciej, if you
okay.
want to do something on the C128, then yeah, we can talk.
Yeah, definitely. I see that you are a freak of this machine. I have one, the flat one, which is a very chimeric, so to say. Sometimes it works, sometimes it's not. Yeah. I'm thinking also about this machine, but currently I just want to go back to the project I started, and I want to develop the engine. I don't want to repeat anything on this engine, honestly speaking, because I don't think that people should be putting much attention into the flipped screen games for Commodore 64. But yeah, I'm just about this scroller thing. But yeah, the Commodore 128 is despite of its moderate success, it's quite interesting machine. Like a C64 should be like this from the beginning, from the architecture point of view, with this MMU and this kind of stuff, because it's yeah, the C64 is simply not expandable. That's the problem.
Yeah, exactly that, because MMU has some underutilized features that people think that C108 is about 80 column mode, but it's in fact you have very nice features in MMU like remapping zero page, remapping the stack, that gives you some opportunities to speed up things.
Or make a multitasking or something like this. I mean,
exactly right.
Yeah.
So I see nice comments. You're a great coder. I love to see your project, other projects come alive next year. Yeah, maybe you bring them back also here.
Yeah, maybe there will be some demo, but I mean December 2025, because I mean I'm a bit exhausted. I also want to now go back to this my retro build tool that I was presenting some time ago, because I have a lot of features that I need to put into. I mean, this game is a multi-part game, which means de facto, even in Kit Assembler, it used the linking process, and this everything here is not straightforwardly supported by my build tool, so I would also extend it beginning of next year, and then see. Yeah, let's see. A lot of stuff I have learned, like this cadaver. I mean, if any of you would like to write a multi-part game for Commodore 64, just use the Lassie Orney fast loader V3, which is damn fast, and also it is even faster on SD to EAC because it supports the proprietary fast loader of that one. I mean, it's super smart and high quality assembly library. I wasn't even able. It is possible to do something like this.
I see. Actually, I see that I missed a few comments and questions for the other speaker on the Facebook page. But then now I see a comment for you here. Great work, Maciej, great stuff. So yeah, everybody seems to like the game, so they will run and buy the box maybe.
Yeah, I mean, the demo is for free. It's even open source. You can find the source code on the GitHub. Yeah, this one I perhaps open also sometime in the next year.
Really nice.
But it's not substantial. It's not substantially different, honestly speaking, from the demo version. It just contains much more assets and more complex linking process. Yeah.
But in practice, then you have two different files, right? One for the color version and one for the monochrome.
No. The game has a quite sophisticated menu system, and you have a sub-menu colors, and then you can select. I want to play the monochromatic or color version, so it uses exactly the same code. I made only one small regression, which means that there is no fade effect between screens in a color version because simply I had no time and memory to code it properly for the 16 colors stuff, because fading in monochromatic was just trivial, and that's the only difference. Yeah. And you can play either the classic one or the color one.
Oh.
Although the title screen, all the game over screen is all color. I didn't manage to make two versions of it. It will be just, very little value for too much effort.
You give too many options. You're too kind with the user. You know, the next step will be that people will ask you to have Tony only in red or in blue. Or...
Yeah, the Rafał Dudek is a crazy guy, and he is just porting this everywhere. So it will be on PC, on Android, on ZX Spectrum, on Atari Jaguar, this kind of stuff, and people are implementing this game everywhere.
Great.
Yeah.
Good, but many thanks again. I don't see more questions. I see just more comments coming. That is nice stuff. So many thanks again, Maciej. I will stop the recording.
Thank you.
Recording are stopped, and yeah. So that's the end for the meeting today. I see from Facebook that my lovely wife is also watching. So I think I just tell her that you can start the pasta. Émilie, tu peux commencer les pâtes. That's private message because she's waiting for me to start dinner. The meeting, so for that's the last one for this year, obviously. As you have seen, we had only 2 meetings, unfortunately, in 24. That's mostly due to myself being traveling here and there mostly for work and being busy with other activities. But we plan, of course, to resume normal frequency of meetings as of next year. So the next one is planned for March 2025. So I hope to see you there then, and don't hesitate to bring your proposal for talks for next year, as usual, on the website. And many thanks again for today. Yes, we can close. I wish you a good end of day and or night, and see you next time.
Thank you.
See you then. Thank you. Bye-bye.
Bye-bye.
Cheers.
Great presentations, guys. Really.
That was a great evening. Completely agree.
Yeah.
Very nice.
I will close the call now. Thank you
Mhm.
again.
Thank you. Bye bye.
Thank you. Bye.
Bye.